Hey, it's Mr. H, and this is episode 10 of my DailyDesmos Graphing Challenge series. So this time, we are going to look at 53 sines, number 0 advanced. And I think that that is a clue to how we want to do this. 53 sines, we must have 53 separate sine waves inside this graph. So let's try to make this graph. And we're going to use something that I did in my last tutorial where I showed how to rotate a graph. So let's get this started. Here we go. I'm going to start off, of course, with a sine wave. So let's just get a nice sine wave on our graph here, and we'll make it orange so it's ready to go. And I think that if I just rotate this sine wave around, then I'm going to have what I want. Now the trick to this is going to be getting all of those rotations just right. And there's a trick there that it says there's 53 sine waves involved. So first, let's get this rotating. So if you're interested in how to rotate a graph, check the little link up here in the corner for my tutorial on how to do that. So here's what I show in that tutorial. I can set up a new graph by saying I want to do whatever the original function was. Well, let me set up kind of the structure of this graph first to make it a little easier for myself. On the top of this fraction, I want to have sine of something minus x sine, and for now we'll just call this a. So the something inside here is going to be x cosine a minus y sine a. And you can see how this operates in my tutorial that I mentioned. But for now, I'm just going to have a slider here for the a. And you'll notice that I can rotate my graph now by doing this. Now, if this was not a sine wave, I can show you really quickly. What if I changed this to a cosine wave? Then I would also want to change right here to a cosine wave. And then I also have an effective rotation, and this rotation is going to be a rotation around this origin point here at 0, 0. So let's change that back. Well, I mean, but while we're here, we might as well kind of explore how this works. What if I had y equals x squared and I wanted to rotate that? I could just go to this parentheses here and do the squaring function, and then I have the rotation as well. So you have kind of a handy dandy equation for how to rotate anything at all. So let's change this back to sine, and we'll change this original back to the sine function just so that we can see what's going on. Now, this is all well and good, but I need all of these to show up at once. So what I want to do is have this go, instead of from -10 to +10, let's see here, we are in radian mode. So let's see what happens if we go from 0 to 2 pi. And we say, let's have the step, I want 53 of these, right? So let's have the step be 2 pi over 53. And now I think that as I go through this, it should kind of be a little bit jittery, but it shows me all 53 of the ones that I need. Now technically, I'm doing that first one and last one are the same. So technically I have, I think, 54 items there. So I will have to be careful with that. But what I want to have happen is I want to have these all show up at the same time. So instead of using a slider, I want to use a list that shows all of these. So if I do these brackets, I can say I want my list to go from 0 to 2 pi. By saying, comma, dot, 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 2 pi. And what this is, oh, that's kind of a neat looking graph, but what this is going to do is it's going to go by ones initially. It's going to say go from 0 to 1, 2, 3, and so on. So that's why I only have these. But what I'd really like it to do is go by increments of 2 pi over 53. So let's say 2 pi over 53 is how, oh, that looks really nice, except notice that there are actually 54 elements and I want 53. You can just make out that this original one is darkened in twice, right? This one right here is darkened in twice. So the only thing we'll need to do is get rid of this first element. And let's say I want to go from 2 pi over 53 to 4 pi over 53. And then I have a 53 element list like I'm supposed to. I can change this to orange and boom, we have a nice sunburst of color and have it in projector mode there. That looks really, really good. So I have a couple extra things here, but also notice I don't need this first line anymore. But what I like to do is condense these down just to one single equation whenever possible. So what I've done is here in my answer condensed, I've shown you can just take this list and insert it where the A's are in our equation. So if you put that in, we can get rid of this and we can look at our answer all in one equation. We have this sunburst showing up here for ourselves. So that is very, very nice. Let's get this exactly like we have by turning off all of the grids. We can look at this. Wow. So challenge met, and remember, here is our equation. But the interesting thing here is this is really about using lists and also using rotation. So again, I'm going to link that video about how rotation of a graph works in Desmos, and you can then use it for any type of thing that you would like. Very interesting. So I mean, while I'm here, why not shift this to some other equation and just see what happens. Let's do natural log and see what happens. Oh my goodness, a sunflower equation. So very, very cool. All right, so I hope you're having fun with this. Make sure that you like and subscribe, and you can keep seeing my Daily Desmos Challenge series every time they come out. Thanks.